Hello students, I'm Gonzalo from Wake 2D IB and CAIE Online Academy. Today we're going to see how to solve the free response section of the 2018 AP Calculus AB exam. This is divided in several videos, so make sure you watch all of them. In this particular video, we're going to solve the parts C and D of exercise 3 of the free response question without calculator of the AP Calculus exam of 2018. In part C, use a trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 to 10. We actually have all the values from 2 to 10. All the values in the table are included in this range from 2 to 10. So we can calculate the trapezoids between 2 and 3, 3 and 5, 5 and 7, 7 and 10. And that's actually 4 subintervals, which is what we have to do according to the question. We can express the integral from 2 to 10 with this trapezoidal sum, the integral of the function h. And since we have to calculate the average value, we need to multiply by 1 over the difference between 2 and 10. So 10 minus 2. So 1 over 8. And then here we have to calculate all the trapezoids. We need to do the average between the y value, the average between 1.5 and 2, and multiply it by the difference between the t values. Yeah? Like a trapezoid, the area of the trapezoid will be, this is a trapezoid, the area of this trapezoid, yeah, we approximate it by the average value. So we're approximating to this area. So we need to use the difference between the x values, in this case t values, and the average of the two y values. So will be 1.5 plus 2 over 2 times 1. This will be the first trapezoid, and then the second one will be 2 plus 6 over 2 times 2, etc., etc. Okay, when we have done it like 1, 2, 3, and 4 trapezoids, after we have the values for the 4 trapezoids, we can do the math, and this is equal to 1 over 8. Then if we add all those values, 65.75, and that gives us 263 over 32, which can also be expressed, I mean, if you do the division, you can express it as a decimal. And this is the approximate average height of the tree over the time interval 2 to 10. Finally, in part D, the height of the tree in meters can also be modeled by the function g, and we are given the function g, where x is the diameter of the base of the tree in meters. Have a look at the variable. The variable is x, is not t anymore, which means when we derivate, we'll have to use the chain rule. We are also given some information. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year, which means the derivative of this function is 0.03. Yeah, because it's a rate. Rate is the derivative. So it's 50 meters tall, but 50 meters is actually the g, the value of g. So we need to find the value of x for which the value of the function is 50. And since negative numbers are not considered, because we will have like a negative diameter, which doesn't make sense, then x can only be 1. Yeah? 100 times 1 is 100, divided by 2, 1 plus 1 is 2, 100 divided by 2 is 50. Yeah, so when g is 50, Yeah, x is 1, so g of 1 is equal to 50. Okay, then according to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? Well, the first thing we need to do is we need to derivate g. We need to find the derivative of g over time. Okay, we need to derivate g of x over time, which means we need to use the chain rule. Yeah, we need to derivate over x, but then we need to multiply by the derivative of x over t. Okay, and this is actually what we are given. Yeah, you see, we are given this rate, 0.03 meters per year is actually the x over dt. Then, well, derivate, we all know how to derivate. So to derivate g, we need to use the quotient rule. Okay, remember, quotient rule is derivative of the top one, which is 100 times the bottom one minus the top one multiplied by the derivative of the bottom one, which is 1, and all this divided by the square of the bottom one, and this is multiplied by dx over dt, don't forget. Then if we simplify this expression, okay, if we simplify this expression, we will get that this is 100 over 1 plus x to the power of 2 dx over dt. And now the only thing we need to do is substitute the x equals 1. If you substitute x equals 1, you will see that what you get is 100 over 1 plus 1 squared times, and then dx over dt, which is the meters per year, is 0.03. If you do the math, you will see that this is 3 over 4. 3 over 4 what? 3 over 4 meters per year. So it's meters, and in this case is the height of the tree. The meters per year that were used here, it's the diameter, the increasing of the diameter of the base per year. But this 3 over 4 is the height per year, meters per year. Thank you very much for watching, and please watch the next videos where I will finish the remaining questions of this exam. Also, don't forget to register for free demo on our website www.victoryonlineacademy.com.